So we've gone over the count vectorizer and n-grams. Now we're going to touch on the last vectorization method that we'll be covering, term frequency inverse document frequency, often referred to as TF-IDF. These aren't the only three methods of vectorizing, but they're the only three that we're going to cover here because they are the most popular. So what is TF-IDF? TF-IDF creates a document term matrix where there's still one row per text message and the columns still represent single unique terms, but instead of the cells representing the count, the cells represent a weighting that's meant to identify how important a word is to an individual text message. So this formula lays out how this weighting is determined. It may look a little bit intimidating, but it's actually quite simple. You start with this TF term, which is just the number of times that term I occurs in text message J, divided by the number of terms in text message J. So it's just the percent of terms in this given text message that are this specific word. So for instance, if we use I like NLP and the word we're focused on is NLP, then this term would be 1 divided by 3, or 0.33. Then the second part of this equation measures how frequently this word occurs across all other text messages. So it calculates the number of text messages in the dataset divided by the number of text messages that this word appears in, and then it takes the log of all of that. Let's just say that we have 20 text messages, so that's going to represent N in this case, and only one of those contains NLP, so that's going to be DF. So the second part of this equation would then be log of 20 divided by 1. So as this fraction inside the log gets larger, the log of that fraction also gets larger. So now let's say that you have 40 text messages instead of 20, but NLP still only occurs in one of them, so the denominator here will still only be 1. So now this fraction is 40 over 1. The term NLP is less frequent, and this term collectively is going to be larger. So basically, all this says is that the rarer the word is, the higher that this value is going to be. If a word occurs very frequently within a particular text message, so that's TF, but very infrequently elsewhere, that's going to be the second term, then a very large number will be assigned, and it'll be assumed to be very important to differentiating that text message from others. In summary, this method helps you pull out important but seldom used words. Enough on definitions, let's jump into the code. So you should be getting really good at this by now. We're going to use the same template as the last two lessons. Again, we're reading in the data the exact same way that we did the last couple lessons. We're instantiating the Porter stemmer and storing our stop words. And we'll go ahead and run that, and then we can go down to our clean text function. So for this cleaning, we're going to jump back to how we treated it for the count vectorizer. Remember, with n-grams, we deviated a little bit from this process because that vectorizer needed a full sentence passed in instead of a tokenized list. But for the TF-IDF vectorizer, we can go directly back to passing in the tokenized list. So we'll define this function, and then we can pass that directly to the vectorizer, just like we did for the count vectorizer, and it'll handle the cleaning, tokenizing, and vectorizing all in one step. So let's go ahead and run this clean text function. Now let's get into actually reading in the TF-IDF vectorizer. So just like the count vectorizer, it's stored in sklearn feature extraction.text. So we'll say from that import TF-IDF vectorizer. Now, in the same way that we did previously with each of the other vectorizers, we first need to instantiate it. So we'll call TF-IDF vectorizer, and then we're going to use this analyzer parameter, and we're going to pass it in the name of our cleaning function. And then we can store this all as TF-IDF vect. Now that we have that stored, we can call the TF-IDF vect and use the fit transform function and run that on data bracket body text column. And then we're going to store that vectorized data in X TF-IDF. Now, just as we did before, we can go ahead and print out the X TF-IDF shape, and we'll print out the feature names from TF-IDF vect. So we go ahead and run that. You'll notice that the shape is exactly the same as it was for the count vectorizer. 5,567 rows, by 8,104 columns. Now that is expected because, as we talked about in the opening, the columns are still represented by unique words. The only difference between the TF-IDF vectorizer and the count vectorizer is what's in the actual cells, not the shape of the matrix itself. Now let's take a smaller sample so we can dive into that and better visualize what's going on here. So we're going to pull the first 20 rows of data and store them in data sample. So I'll grab the first 20 text messages. And then we can just grab this code up here and we can basically just copy it down. And we can just change the name of our vectorizer, our vectorized data, and the data that we're running it on. So we'll change TF-IDF vec to TF-IDF vect sample. Then this is called 2 more times in the fit transform, and then get feature names. Then we'll change X TF-IDF to X TF-IDF sample. And then again, we'll call that for the shape. And lastly, we want to run this all on data sample, not the raw data. Okay, so this looks as expected, similar to what we saw before. 20 rows, 192 columns, the same as we saw when we did this for the count vectorizer. And the feature names are as expected. So now let's create a data frame from the sparse matrix and add in the column names so we can look at what this full data set actually looks like. Again, we're going to take this X TF-IDF sample that we created just above, and we're going to call this to array to change it from a sparse matrix into an array. And then lastly, we'll wrap this in pd.dataframe to create a data frame out of all those arrays, and we'll store that as X TF-IDF df. Now, if you recall before, we can assign the column names by just saying TF-IDF df.columns, and then call the TF-IDF vect sample vectorizer and call get feature names. And then let's go ahead and print out XTF-IDF df. You'll notice this looks a lot different than our other matrices. Instead of regular integers in these cells, you have decimals. This 0.2316 is likely more important than this 0.1977. So this 0.2316 is likely more important than this 0.1976. Now what that means is either 12 occurs more frequently in the 5th text message than 11 does in the 6th text message, or it means 12 occurs less frequently across all the other text messages than 11 does across all the other text messages. So in summary, we kind of created this false choice here, indicating that there are 3 different ways to vectorize. These are all very closely related though, and some can actually be used together. So TF-IDF is basically count vectorizer that includes some consideration for the length of the document and also how common the word is across other text messages. And then ngrams is just used within either of these 2 methods to look for groups of adjacent words instead of just looking for single terms. So they're all just slight modifications of each other, and typically you'll test different vectorization methods depending on your problem, and then you let the results determine which one you use. So that wraps up our vectorization section. Next, we're going to learn about feature engineering.